All right, it is 8:30, so we'll go ahead and get started. So this week in the course content was all about Python functions. So what is a function? A function basically boils down to Python code that exists somewhere else. It can be code that somebody else wrote. It could be code that's automatically just built into Python itself, or it could be other code that you have wrote. You can make your own functions. And we'll see how to do that a little bit later. But first, let's look at a couple of the Python built-in functions. So one of them you've already been extensively using when we talk about wanting to print something, right? Say print 1, 2, 3, 4, right? This print this print is a function that exists. It's built into Python, but it's code that exists somewhere else. You say print, and then you tell it what you want it to print. And of course, we can save and run that. It doesn't really do much. It just prints out whatever you tell it to print, right? But the code, the Python code that actually does that work to put it on your screen is located somewhere else, and it is a function. Okay, so let's look at a couple other built-in functions. There is a built-in function called max. Let's say if we want to compare two numbers together. We'll say we have big equals the max, say, of 1 and 2. All right, and then we will print what the variable big is. So this Python built-in function called max, it takes two numbers and then it'll give you the bigger of the two numbers. And then I just want to print that out. So let's save it and let's run that. And there it tells us the max number out of those two numbers is 2. Okay. Conversely, we have a Python built-in function called min. Right? It'll give you the smaller of the two numbers. Right? And of course it does. It tells us that 1 is the smaller of those two numbers. Those are just a couple of the Python built-in functions. We're not going to go through all of them, but it's just to show you that when we talk about a function, just think of it as code that exists somewhere else, that either it's built in, someone else wrote it, or you wrote it yourself. But it's code that exists elsewhere, that when you call the function, and that's what we mean when we say call a function, we put in the name of the function, and then we give it the values that we want it to operate on, what it expects to receive. Okay, so that's an example of the min built-in Python function, and an example of the print built-in Python function. And you don't need to know how it figures out the min. You don't need to know how it does the print. The only thing you need to know is that's the name of the function, and I'm giving it what I want to print, or I'm giving it, the two values that I want to compare. Let's make this bigger. That'll probably help some. Okay. So let's think about some other functions. There is another set of functions, let's say math functions. If we want to use math functions, we have to start out with an import math. And what that means is the math functions aren't automatically built into Python, but they are functions that someone else wrote. They exist in another file somewhere. The file where those functions exist is called math. And this is how we specify that we want to use those other math functions. We say import math. And this has a bunch of functions that somebody else wrote. You don't really need to know how they work. You just need to know that you can use those functions to accomplish some work. So one of the math functions is to compute the sign of a value, right? So we can have s equals math dot sign, and let's give it pi. So, and then we'll print s. We can also do the cosine of pi. Cosine equals math dot cosine, 3.14. So we'll print S, and then we'll print C. Let's save it and run it. As you see, there's the answers it gave us. So even though I didn't manually compute in here anywhere, I didn't figure out how to get the sine of it. I didn't figure out how to get the cosine of this value. I used someone else's code that someone else wrote to do that computation for me. And so all I have to do is, since those functions are contained in a file called math, I import that math file, and then to call those functions is math dot, and then what you actually want to do math-wise. For this is the sine, for this is the cosine. Okay, and there are many math functions. I think there's an absolute value math dot. I think it's ABS. If we put -3 in there, it should give us a 3. I think it's ABS. Save it and run it. Nah, it's not called ABS. It's something else for absolute value. And you don't necessarily have to memorize. This is how I do sine. This is how I do cosine. And well, that wasn't the absolute value. It's something else for absolute value. You can look at the documentation for it. You can go on a search engine and type in, Python math library, and it'll give you a whole bunch of these math functions that is part of this math library, right? Another one is square root, right? Let's try the SQRT. What's the square root of 5? I don't know what that is off the top of my head, obviously, but we can ask this math library to tell us what the square root of 5 is. If we save that and run it, and this is the square root of 5, right? And so these functions exist in another file that someone else wrote, but this is how we use those to do computations that we want. And it doesn't necessarily have to be computations. For example, this print function that exists, it's not computing anything, of course, it's just printing out to our screen whatever we tell it to print out. So let's talk about making our own functions. Okay, so as we said, Python has a few built-in ones. This math file has some functions that we can use. Well, someone else wrote those math functions. Well, how can we be that someone else, right? How do we make our own functions? Let's make a very simple one. Let's say we want to make a function that prints something out twice. For whatever reason, it just prints out something twice, okay? How we make our own function, we start off with DEF, that stands for define. That's what it stands for. And then we name the function. We can call it anything we want. We can literally call it anything we want if we wanted to, But it's useful to name it to be something like what it's actually going to accomplish. If for our example, we're just going to have it print something twice, so let's call it just print twice. That's the name of the function, print twice. And so then we do define, we name the function print twice, we put a colon, and then we put the Python code that we want executed when that function is called. So for example, we'll just say once, and then we'll print twice. Okay. So let's delete all this other math stuff down here. So now we have this function called print twice, and it'll just print once, and then it'll print twice. Okay. So let's save it. So if we run this, what is going to happen? Well, let's see. Let's see what happens when we run it. Run it. Oh, I'm sorry, I missed one thing. We have to put these brackets in there. And we'll see what goes inside those brackets in a minute. You can put things inside those brackets. So that's what the definition of, that's how a function looks like. It's define, the name of the function, the two braces, and then the semicolon, and then what you want to happen when the function is called. All right. So now let's save it and run it. And it doesn't look like anything happened. And that's actually correct, because we have defined a function. We have said what this function is supposed to do, but we haven't actually executed that code. And so we execute that code just like we would call any other function. For example, when we did print something, right, we called the print function and we told it to print this, right? So we have our own function here, and we need to call that function. Just like we called the built-in print function, let's call our print twice function. So now let's save this and let's run it. And there we go. It prints out once, it prints out twice. And the good thing is we can do this multiple times. Let's say we want to do it 3 times, right? If we save it and run this, it prints out once, twice, 3 different times. And that's really the power of a function right there. I mean, this is kind of a silly example, and we'll get to better examples. But instead of doing all this code, writing all this code multiple times, we only do the code one time for the whole function, and then we can call it as many times as we want to. Okay, so let's stick with the example of just calling it one time. Save that. So that's how a function works without giving it any external input. As you can see here, what we print out is kind of set in stone. We manually typed in, this string once and the string twice. But what if we want the user down here to decide what to print out twice? Well, just like with our print function, in here, we tell it what we want it to print, right? Well, let's tell our print twice function what we want it to print. So this is where you get into where functions have what we call arguments, meaning inside of these braces, we are saying what we expect you to give the function. So right now, I'm just going to call it SSSS. What this has done, it has made a new variable that exists only inside this function. It does not exist outside the function. It only exists as part of this function. There's a variable SSSS. And what I want it to represent, I want it to represent what I want to print out twice. So let's change this to SSSS. So now we have a function that takes this as an argument, and whatever that is, it can be anything. Whatever it is, we are going to print it out twice. Okay. So now when we call the function, we have to tell it what SSS is, right? It can be a number, for example. So if we call print twice with this 3, when it comes up here to this function, SSSS is now that value of 3. If I put ABC in there, when it comes up to the function, SSS is now the string ABC. So let's save it and let's run it. And you'll see that this will print out ABC twice. We run it, and there it is, ABC, ABC. The power of this is we can call it print out twice something different. So this should print twice ABC, and then this should print 3 twice. Let's save it and let's run it. And there it is, ABC, ABC, and 3 and 3. And we'll get to why this is important in a minute. But you need to be able to mentally make the connection that what you put inside of these braces translates into the function of whatever this variable name is. And we can have more than one. It doesn't have to be just one. We can have SSS and say TTTT, right? Let's just, if we do print out like this, right? So now we have a print twice. It takes two arguments. It takes this first argument and it takes the second argument. And what it'll do, it'll print out the first one twice. It'll print out the second one twice. So now down here where we have our print twice, right now I'm only giving it one value, but we need to give it two values now. And why? Because it expects two different values. That's what the comma separation means, is this is the first variable and this is the second variable. So when we're calling the function right now, we've only given it the first variable. So we need to give it the second variable. So now when we call this function, this ABC gets translated to this variable. The DEF gets translated to this variable. So we save and run this. We'll see ABC, ABC, DEF, DEF. And of course, this can be the 3. It can be a number. That's fine. The important part of this is just making that mental connection that this first value, this string, translates into this variable. This second value translates into this variable. And no matter how many times you do it, say print twice with X, Y, Z, or actually, let's do a number first, a number, and then X, Y, Z, right? That works fine. It'll do these printed out twice, then it'll do these printed out twice. Let's save it and run it. And there you see it does print them out twice. Okay, so let's actually do something useful with this instead of just doing something silly like printing something out twice. Let's say we want to calculate the area of a circle. What is the area of the circle? The area of a circle is area equals pi times r squared. Let's just write it kind of in English. Area equals pi times the radius squared, right? That's the formula for the area of a circle, right? So let's have the user input what the radius is. So we'll say R equals, have them input, say enter the radius, right? And for right now, let's just print out what the R is so we can see it works. So right here, we're going to ask the user to enter the radius, and then it'll just print the radius for us. Let's take it slow, one step at a time. So we run it, enter the radius is 4, and it kind of just echoed that back out to us. It says, R is 4, because that's what you typed in. Okay. So let's actually calculate the radius. So we'll have area equals pi, pi is 3.14, and then some other stuff, times the radius. And to do squared, or to do any kind of powers in Python, it's ***. This right here just means radius squared. We could have done, radius times radius. I'm not doing a math class, so, but that's radius squared. But also in Python, you can do ** and then the power. If we want to do radius to the 10th power, it would look like that, right? But for the area, it's radius squared. So that's calculating the area of a circle. So let's print out the area. Okay, let's save it and run it. And so if my radius is 4, radius is not defined. That's because I used R for my variable, so I have to use R as the variable I calculate with. Okay. Let's save that and run it. It'll work this time. Yeah. And there you go. So the area, if the radius is 4, the area is, that. Right? Let's do it 2 times. Let's calculate that area. Actually, let's not even ask the user anymore. Let's just type in what we want it to be. So have R equals, say, 1. We'll have R equals 2. Let's do it some more. Say radius is 3, right? So we have all this code setting the radius to a certain value. We're calculating the area, and then we're just printing out the area. Let's save it and run it. And there's the area for those various radius, for those different radius. Okay. So what you see here is a bunch of a bunch of identical code repeated over and over, right? You're seeing this exact same code repeated 3 times, right? There is no difference whatsoever between this code. The value of R is different each time, right? But this formula, this line of Python is identical. That's a good indication that you should write a function for it when you have identically repeated code. So let's make a function that computes the area, and then we'll use that for our example. So to make a function, we do def for define, name it whatever you want. I'm going to say calculate circle area. Inside these braces, we have to put what the function is expecting to receive as an argument. Right now, let's leave it blank. Then we have the colon. And now we actually do the calculation we want to do. And so for area, it's this right here. Okay. But this function, it's making a new variable. It's using the value of pi. It's using the squared. But it's also using R. This function has no concept of what R is. R exists outside the function. Down here, this stuff is outside the function. But inside this function, R, it has no concept of what R is. But we can pass it as a parameter, as an argument. We can say for this function, when you call it, you need to give me the radius. And then we could use that in here to calculate the area. So now whenever I call this function, and we'll call it in a minute, we'll call the function, we'll give it the radius as a parameter, then this function will do the computation, and then there's one more step we have to do. We have to return the value. So the function takes this argument, it does the computation, and then it returns the value that it computed. And so how do we use that? Let's delete all this out of here. Okay. So let's call our function. We can call calculate circle area. As an argument, it's expecting you to give it the radius that you want to calculate the area for. So let's say of a radius of 1. Okay, we can do this a bunch of times. 1, 2, 3. Right? So that's going to calculate the area with those different radiuses. We save it and run it. It doesn't look like anything happened because we didn't actually print anything out. But what happened is it calculated those 3 areas. So what we can do, we can say A, there we go, A equals that. And so what's going to happen here is this function calculate area, calculate circle area, it returns this value. So when we say A equals that function, A will equal whatever that value is that got returned. So if we ignore these other calculates for a second, let's say we print out A, what do we think is going to get printed out here? Well, what's going to happen is we call our function with a radius of 1, does the computation, it returns the value gets saved in this variable A, and then we just print it out. So this should print out actually 3.14 as the area. Save it, and let's run it, and there you go. That's the area that got computed. We can do this for other radiuses. You say the radius is 2, the radius is 3. We save it, if we run it, that is the correct area for those 3 different radius. Again, the mental connection that you have to make is that this value here, this 1, gets translated as to this variable called radius. It does the computation with that variable. It returns this value that it computed. This returned value gets saved back to whatever you use the variable equals, right? So this variable equals whatever is returned from this function. Okay, so that is, I say that's all there is to functions. It is a little bit of a complex topic, but that's how functions work. Okay, let me cover a little bit about your assignment, and then we'll open it up for questions. So your assignment is to, ask, you're calculating the cost of some carpet, right? So it's asking you to write your own function that takes 3 arguments. I think it's the length, the width, and the quality of the carpet. And then you return the cost, right? So that's really not far off what we've done here. So actually, let me let me add the user input back in here. Input, enter radius. Let's delete these other ones. We don't need them. So for your homework, you have to make your own function, like I've made my own function. Your function needs to take 3 parameters, the length, the width, and the quality. Mine only takes 1 parameter, but there's nothing stopping me from putting, radius, and then say, when I say parameter and argument, those 2 words can be used interchangeably. So I know sometimes I say parameter, sometimes I say argument. They mean the same thing. So, I've made a function with 1 argument, but you can have 2 arguments, you can have 3 arguments, you can have 4 arguments, that's fine. That's how you get the other arguments. So I've made a function with 1 argument. It does a computation. It returns the area. Yours needs to return the cost. So you need to do some kind of math in here that computes the cost based on those arguments. So for example, I might have length, I might have width, I might have quality of carpet. And then in here, I'll have to do, figure out the cost based on those arguments. But for the example, we just have 1. And then you have to return the computed value. For you, it's cost. For the example, it's area. And then your assignment says you need to ask the user, what's the length, ask the user what's the width, ask the user what's the quality. Here, I've only asked the user, what's the radius, because that's the only thing I need. Then I call my function with the user input, and then I am just printing out what that computed value is. So this is really fairly close to what your assignment should look like. You just need to think about having additional arguments in here and doing a different computation. This is the computation for an area. You need to do a computation for the cost of the carpet. It's the area and some quality type things. But this is very, very similar. Let me see if there's anything else for your assignment, but I think that's it for your assignment. Yep, just having a function and computing the cost of the carpet. Things I've seen in past classes where people will mess up is they won't even make a function. They'll just ask the user for the length, the width, and the quality. Then they'll just compute the quality and then print it out, or excuse me, they'll compute the cost and then print it out. They won't use a function. You have to have a function or you're going to lose a lot of points. And the reason being is to force you to figure out how to make your own function and how to use a function. So make sure you actually make a function for the assignment. And that's this week's material along with the assignment. So I will open it up for any questions. It can be about this week or any of the previous weeks as well.
Yeah, I have a question.
Yep, go ahead.
So my question is, so you want us to include the length, the width, and the quality of the carpet. Now, the quality in my mind, I mean, it's not a value. How do you calculate length, width, and quality to determine the price?
Okay, so let's go back to our
Yeah, I'm
example
sorry
here.
if this go into the assignment, but it's just a little bit.
No, that's actually a good question for the assignment, because the cost is not length times width times quality. That doesn't make any sense. A quality is like low quality, medium quality, high quality. It's something like that. So let's kind of translate that into our example here. So let's say instead of calculate circle area, let's just say it was calculate. Let me think the way to do this without giving the answer. Let's say cost of a car. Forget about the area and stuff like that. Let's just say we want to calculate the cost of a car, right? And so let's say we want to enter, let's say the cost of a car is based on two things: the year it was made and is it a high-end car or a low-end car? Okay, so that can kind of translate into your carpet. Is your carpet high-end? Is your carpet low-end? Let's talk about cars. You can have a high-end car or low-end car. So let's say our cost is based on the year and the quality of the car. Okay, so we'll say we'll have them enter the year, and then for quality, we'll just say enter quality, and let's let them know what valid choices are. That's kind of important. It can be high or it can be low. High or low. Okay. And for just our testing purposes, take it slow. We'll just print back out what they typed in right now. So don't worry about what the function is doing. This isn't working yet. It's not doing anything yet, because I haven't figured out how I want to calculate it. We'll just have them enter the year, and then we'll have them type in what the quality is, high or low. As you can see here, I've just left it as the input. I'm not making it an integer. I'm not making it a float. So that means by default, this is whatever they type in is a string. So let's just run this. and enter the year. It's a 1990 car. And is it high or low end? It's a high end car. And then of course, it just prints out to us what we typed in, right?
Mm-hmm.
So let's call our function. We'll say the cost is equal to the cost of the car. The arguments it's expecting the year and the quality. So let's give it what the user typed in, the Y and the Q. Oops. And then we will just print out the cost. Let's run this. Right now, it's just going to be, the cost is going to be 0 because that's what we're returning. Up here in a second, we'll fill this out to do a calculation. But here, we're just looking at how to call the function, what arguments to give it, and then it returns the cost, and then we'll print out the cost. Let's just save it and run it. So 1990 high-end car, and the cost right now is 0 because we haven't done the calculation yet. Okay. So we're just going to make up a formula here because I don't know a real formula for the cost of a car. So let's say the cost of a car is its year. Let's say that'll just be it. Let's not consider the quality yet. Let's just say the cost of it is equal to the year it was manufactured. So if it's a 1990 car, then it costs $1990. If it's a 2000 car, it costs $2,000, right? So we're not taking into account quality yet, but we will. So let's run this. If it's a 1990 car, oops, got to run it first. There we go. It's a 1990 car. It's low quality. It costs $1990 because we said the cost of it is only based on the year. Okay. Well, now let's take quality into account. So we know quality is a string. And we know that because when I did the input, I just did input. I didn't do an integer. I didn't do float. I didn't do eval, right? So it's just a string. So this Q is a string, and we're giving that string as what the quality is. So we can use some if statements here. We could say if the quality is high, then we want to do something.
Oh.
Do something.
Okay.
Else, if the quality equals low, do something else. And then we can have like a catch-all. If it's not high or low, do something else. So let's say if it's of high quality, let's say the cost will be the year times 2. If it is low quality, the cost is just the year. And if it's not high or low, maybe they typed in something wrong on the keyboard, then it's free, right? And then we need to return that cost. So what we've done here is, if I type in high on the keyboard, then this variable Q is high. The variable Q is the argument up to this function, so quality is high. And so now I'm saying if the quality is high, then that's how much it costs. Okay. If I typed in low for the quality, that's how much it costs. And if I typed in something besides high or low, that's the cost. So let's run that. Let's go down here, save it. Let's run it. And the year is, let's just say 1000 to make the math easy. It is a low quality car, and you see that the cost is 1000. If we run it again, and we say it's a high quality car, the cost is 2000. And if we run it again, and we just kind of typed in something that's not high or low, the cost is 0. And it was based entirely off of these if-else statements. So maybe for your carpet, you have high, medium, low. It can be any words that you want to use, right? You can put excellent carpet. You can have bad carpet. The words you use aren't that important. As long as you're consistent with whatever the user types in, that's what you need to check with these if else statements. So that's how you can kind of incorporate a quality into a mathematical computation. Does that answer your question?
Yeah.
Okay.
I did mine a little differently. Can I get my assignment back so I can fix it?
There's more than one way to skin a cat. So if yours works, it works. But if you do want to redo it, you can just resubmit it, and I will grade the most recently submitted assignment.
Thank you.
Hey, Professor, I have a quick question, but it's actually in regards to next week's assignment. Just a quick question in regards to it.
All right, go ahead.
I was looking at the description of what's required. At first, it looked pretty easy. I think it just said, come up with some grades and use like a list function to make it work, right? I ran into an issue in where I can make the list run, right? The students or whatever, but how am I trying to say this? The lists are set so you can run a list, and it's going to prompt you for each of those elements within the list, right? If you kind of get what I'm saying.
Yes.
I'm having an issue where it prompts for me to enter input for each of those elements, but those elements just disappear after the next line runs. I'm not sure how I'm supposed to, how to cement those individual inputs as variables. The only thing I could think of is to append it to a new list, but we didn't do any of that during the actual weekly assignment, so I'm thinking that's the wrong answer.
Right. So for this, the assignment says it should compute and display the average of those 5 grades and the highest grade, right?
Mm-hmm.
So to compute the average, do you need to remember each individual grade?
Well,
no, you only need to remember the sum of the grades, right?
Copy. And I did figure out a way to do that without using an append command.
Mm-hmm.
And I got it to do the average, right? But then the hard part is to identify the max grade, because again,
Okay.
each time you punch in a different number, let's say, that number has nowhere to go, or is nowhere to be assigned to. And so once the next number takes it, there's no way for me to say, hey, look, remember the highest grade, if there's no way to record all those individual numbers for them to have some kind of comparison done, like a max command, or like some of the stuff we went over was to come up with a loop that determined the highest or the largest number. I don't know. I'm confused. Like I said, I was trying to get to the answer without going outside of the student lessons, and I was just running into issues all day today. So.
Okay, so how do we find the highest number that exists that the user types in? Okay, so let's do a quick example. Let's have a loop. Let me find a better way to do this.
Sorry, I explained it terribly,
so,
but I didn't want to give the assignment away without for people that haven't got there yet.
No, I understand what you're saying. So let's have the user type in a number, right? So a number equals integer input, enter a number. something like that, right? So let's do this in a loop to make it do it a bunch of times, right? I don't think, have we gotten to loops in this class yet? I don't think we have.
Not yet.
Okay, well, so let's do it without loops, all right? Well, no, we'll do it with loops. It just makes it easier. So let's say we have these numbers 1, 4, 6, 10, 23, 43, 1, 7. Like I said, you guys will see more of this in the content for next week. But what this is saying is this is a list of numbers. It's not a single number. You know, if we have something like that, that is a single number. N is a single number. What this is, it is a list of numbers. It is multiple numbers. And it's denoted with these beginning and ending brackets here. That means this is, you know, what is this, like 8, you know, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it's 8 numbers, right? So it's saying it's a list of 8 numbers. And we can go through that list with what we call a loop. The easiest loop we can do is say for n in numbers. What this is meaning is it is going to loop and execute the same code multiple times, and it's going to use these numbers. That's what the n numbers means. This part means look in this list, look at all of these individual numbers. And each time the n is going to represent a single one of those numbers. So the first time in the loop, the n is 1. The next time n is 4, then n is 6, then n is 10, and so on and so forth. So if we just print n, let's take this out for a minute. What we'll see is all of these numbers will be printed out individually. So it'll loop how many ever numbers there are, and each time it just prints out the n, with the n representing those individual numbers. Let's save it and run it, see what it looks like. As you can see, it just prints out those numbers one at a time, exactly as they appear in this list. So that's how we can go through all the numbers. That's how we can access all of those values. So let's say we want to find the biggest number in there. What is the biggest number? Let's have a variable called biggest. Is it no? No, it's none. Sorry. So we're saying this variable biggest is equal to none. And what the none represents in Python is nothing. It represents no value. It is not 0. It's just saying I have a variable and it has no value at all. Okay? Okay. So in here, we want to find the biggest number. So we need to say, is n bigger than the biggest one, right? But really, we need to figure out if biggest is none, meaning it has no value yet, then the biggest can be n. So if biggest is no value, then biggest is now this first n value. Else, if biggest is less than n, then biggest equals n. And so let's think about this logically. So biggest starts out with the value of none. Now we start this loop. The first time n is equal to 1. So we're saying if biggest is none, right now that is true, right? Biggest is none. Okay, so now we're going to say biggest is equal to n. So now biggest is the number 1, right? And so it doesn't get to the else statement. So it goes back up and does the loop again. Now n is equal to 4. So we're going to say if biggest is none, that is no longer true because biggest is 1 now. Biggest became 1 in that last loop, right? So that is no longer true. So now it'll go down and check the else. Now it'll say if biggest, which is 1, so if 1 is less than 4, that is true. The biggest is now 4. Okay, now we're going to go through the loop again, and now n is 6. So now we're going to say if biggest is none, that is not true because biggest is 4. So now else, if biggest, which is 4, if biggest is less than 6, that is true, then biggest is equal to 6. And it'll keep repeating the same loop over and over and over, so that by the end, after the loop is done, not the biggest, the biggest. It should be the biggest number in there. Save it, and was it? It should be 43 at the end, right? Run it. Oops. Sorry, it's not else if, it's elif. Else if is like C programming language. Elif. All right, so let's run that, and you see it found 43. So it found the biggest number in that list of numbers. Conversely, we can also do the smallest number if we want, right? So if we call this smallest, and change all those from biggest to smallest. So, but instead of doing the less than comparison, we just need to change the comparison around to get the smallest number. Save it and run that. Should be 1. And is 1 the smallest number? Yep, 1 is the smallest number.
Copy. I guess my question kind of goes back to the question's asking for a list of 5 names, which are strings, right? So,
Yes.
I mean, if we're dealing with a list that's made up of strings and we execute that list, right, with the for loop, correct? Mm-hmm. Everything that it asks is going to be a string, not necessarily a definitive number, right? Where if it's a string, it's apple, orange, pear, pineapple, and you look for the biggest one, it's just gonna it's not gonna come up with anything because it's a string. It's not necessarily an integer or a float number. I think that's where I'm having issues because it's asking to say, hey, look, repeat these 5 strings and have an entry for each of those strings that can be summed into an average, correct? When it executes, sorry.
It's asking to average their quiz score, not their string name. So
yes, but if we run the list with this for command, it's going to say, all right, let's say apple, and I say 6, and the next one goes down, I say 8. At the very end of it, I could sum all those by using like a function. I could define a function which kind of adds all those up, but I'm still having issues where do those numbers go? Let's say I put an input. What does that input associate with that I could
okay. So let's just do a sum, right? So.
Well, can we do it with a string? Show me with I'm sorry, we're talking about next week, but.
No, that's fine. I mean, as you can see right here, I've now changed my list to be these strings, right?
All right.
It's A, B, C, D, right?
Yep.
I can say print the S, right? And that'll just print their string, right?
Yeah.
But now I want to ask, how many dollars is that or something, whatever. I can have a new variable, D is equal to an integer input, enter a number, right? So I can sum plus D, right? And now I can print, down here at the end, I print the sum. So you're not adding the string, you're adding the number that the person input, right?
But each input, isn't that going to be D now? Because it's going to ask the same question every time, but for the different, the next element within that list.
Yes, so imagine this S is your names, Bob, right. Joe, Charlie, and let's just leave it at 3 right now. Okay. Enter, I don't know how much they weigh or something, right?
Mhm.
So each time through here, we're going to print out their name. Then we're going to ask the user to enter the weight. And then we're summing up that weight. We're not summing up their names. So at the end, we can print the sum, and we can print, was it 3 names? Yeah. Then we can print, that's how we get the average, right? The average is the sum divided by how many you did. And so the sum divided by 3 is the average for those 3. So if we save it and we run that, let's just say Bob weighs 10, Joe weighs 20, Charlie weighs 30. The sum of their weights is 60 and the average weight is 20. So nowhere in here have I done any kind of, addition or anything like that with the string. The string was only there to print out their name.
Gotcha.
So that you know whose weight you're entering.
All right, I think that I think I had that down, but like I said, once again, like the numbers that we're inputting, if we were going to find out which one was the biggest, those numbers just kind of disappear every time the next element injects itself, or do they go somewhere?
No, that is true. They do disappear. That's why you have, and like we did a few minutes ago, that's why you have to keep a variable that keeps track of the biggest. So here you see if the biggest is equal to none, or the biggest is less than, the weight now, then the biggest is equal to the weight. So now at the end here, print the biggest. If we run that, forgot the semicolon or the colon there on the end. And our weight, they weigh 10, they weigh 20, they weigh 30. There you go. That's the sum, that's the average, and that's the biggest one of 30. It doesn't matter which order you do them in. You could do 20, 30, 10, and it still figures out that 30 was the biggest. But that's because we kept this other variable around, this other variable called biggest, so that you're right, each time through the loop, the D becomes something completely different and we lose it the next time in the loop. That's why we have to keep this other thing around to keep track of what the biggest one was.
Copy. Yeah, I could not wrap my head around that second part you just explained before. And like I did it like 12. I wrote 3 different Python scripts doing the same thing in different ways, but for some reason I couldn't wrap my head around that one. So I appreciate that. I think that's what I needed. So
okay.
A question is the biggest where it equals 9. Is that equivalent to an empty list?
No. Well, it means it has no value. It's not a list. It's not a number. It's not a string. It is none. It is nothing. So actually, I mean, for this example, biggest was going to be a number, right? Because we assign it to be a number down here. But there's nothing stopping you from saying biggest is equal to, a list or something later, right? So biggest is no value. And actually, we can do, what's it called? Print, is it type? Yeah, type of biggest. You should have seen this in, I think, this week's material. Is this, we talked about functions. We have this built-in Python function called type. And what type does, it tells you what kind of variable it is. It'll tell you if it's a string. It'll tell you if it's a integer. It'll tell you if it's a float. It'll tell you if it's a list. This, I believe it just says none. I don't remember the exact word. Let's see. Yeah, it says it is none type. So it has no type. It's not a list. It's not a number. It just is in the void. It doesn't mean anything yet.
Gotcha. So it's basically the only reason why you're creating it is just to have a variable for it to recognize?
Yes, because I need to know. I use the none there because inside this loop, I don't know if it's the first time the loop has executed, the second time, the third time, the fourth time. I don't know how many times it's executed, right? So if I leave out the none, if I just say if biggest is less than D, this is very ambiguous what's going to happen if biggest has no value yet. So in the first time in the loop, I don't know what biggest is, right? Because I haven't entered any of the weights yet. So I don't know what biggest is. So it's what they call undefined when you do this comparison, because biggest is nothing and you can't compare nothing with something, if that makes sense.
Gotcha. Yeah, yeah.
So that's why I do the check. If biggest is none, or, so it'll do, if biggest is none, then it'll do this. Or if biggest is less than D. That way I kind of catch both of those cases.
Okay. If anybody has any other questions about this, I have a question about the assignment that's due this week. So my question is, you were saying there's different ways to skin a cat. So I created my assignment. I created the definite or defined function with the parameters. Technically, my computation is within that function, but I don't have a return on it. Does it have to have the return? I mean, it computes everything, and everything is within the function, and it does meet the parameters, but I just did it a little differently.
The assignment does say, though, that the function must return the cost.
Gotcha.
And then you print. So your functions, inside of your function, you should not be asking for you should not be asking the user for input inside the function.
Okay.
You should also not be printing out from within the function.
Okay. Yeah, I did something called a recursion. I think that's what it's called.
Mm-hmm.
Where I created everything within the function, and then I called that function into the main body. Let me take a look at it. Yeah, 1 second. Let's see. Yeah, I did everything within the function, and then I called it and called the function into the main body. So I will be pulling my paper and redoing it.
Okay. Yeah, what you don't want to do is, let's just make it like a dummy function here, right? Let's call it, the function name is ABC, and we want parameters Q and W, you know? It's not going to be anything meaningful. And let's say we say Q equals input, something, whatever. W equals input, something, right? This is what you do not want to be doing. And the reason being is, in your main, when you call the function, let's say you give it this, it's just two numbers, whatever. You're already giving the function what the Q and the W are. Q is this number 1, 2, 3. W is this number 4, 5, 6. So you don't want to ask the user to input it here in the function.
Okay.
Even if you left this blank, well, you can't really, you can, but it'll be an error in Python if you leave it blank. But you really don't want to ask for input here. Really, the only thing you want to do in your function is do a computation and return the result of that computation. So, if we give it a couple numbers, so we're calling the function. Now we want to save the result of that computation, meaning S is equal to whatever the return was. And then we can print S. So actually what happens if you don't have a return here? I can't remember if it's an error. Let's see. Yeah. So it prints out none. You remember we already talked about what none means. And that's because since we didn't have a return here, we said S is equal to whatever the return was, but there was no return. So S is none. So that's why you have to have that return. For the assignment, the return is going to be the cost that you computed. So we'll return the cost, and then that will be what is in your S variable. And that's the result of it. So in the function that you create, you really don't want, especially for this assignment, you don't want to be asking for input, and you don't really want to be printing in here. But you do need to return the cost because that's what the assignment's asking you to do.
Okay, thank you.
Hey, Melissa, thank you for bringing that up because I did the same thing. I printed the cost with a format instead of returning the cost within that function. So I'll have to go back and fix that myself. So.
It does ask you to print the cost after the function. So, you do need to print down here in main so you can, print out what the cost is to the user, but it shouldn't be in that function.
Copy it. Yeah, just copying, adding that return and then copy and pasting our print stuff somewhere else. So cool. Awesome. Thank you.
I have another question. So I was working on finding the assignment that was due this week. I was trying to create a list to show the maximum. I did like a jogging journal, and I think I did like the max distance, and I was trying to do the minimum time, like that's the fastest time. And I couldn't, because what if the person put in 0? Like, as if they didn't run that day and they put in 0, and I couldn't figure out how to skip the zeros.
Okay, so
to find the next.
Yep.
Or
So okay. Let me see if I can undo this until I get back to my biggest and smallest stuff. Yeah, there we go. All right, so this was looking at the biggest. Let's again change it to the smallest. So let's find the smallest weight, right? Let me delete all these other ones out of here. Biggest. Let's delete all this other stuff that doesn't make sense. Yeah. We don't want to do the sum anymore. All we're going to do is just look for the smallest one. Okay, that's the minimum amount of code. So we're going to look through these three individuals, and we're going to ask them for their weight, and then we want to find the smallest weight. But for your example, if they put in a 0, we just want to skip that. We want to pretend like that's like they don't want to tell us their weight or something. I don't know. So when we're doing this comparison right here, we're saying if the smallest is none, actually we need to flip that sign around. So if the smallest is none, or if the smallest is greater than what they've typed in now, then that's going to be the new smallest. So if we run this now, we'll account for the 0 in a minute. So if we run this now, the weight is 1, the weight is 2, the weight is 3, the smallest is 1, right? If we run it again, you have 0, 1, or 2. It says 0. But for your question, we don't want to account for 0. If they type in 0, we want to skip it, right? So what did I say? I said, if they type in 0, then skip it, right? If what they type in is equal to 0, then skip it. Else, do this check. So now, if D is 0, we're going to skip it. We're not going to do anything. We're not going to make this comparison to see if it's the smallest or not. So let's save it and run it. Oh, you actually have to have something here. So actually, let's change this around a little bit. If it's not equal to 0, then we want to do this. So if D is not 0, then we're going to make this check. So if their weight is not 0, then we're going to try to figure out if it's the smallest or not. If they do type in a 0, it's going to skip this, right? So we save it. If we run that, so enter weight. If we show it still works. If we enter 1, 2, 3, 1 is the smallest weight. If we type in 0, 2, 3, 2 is the smallest weight. It skipped the 0. So what you have to have an if statement that specifically states under what conditions you want the code executed. And so you said if it's 0, then we want to not include it in our calculation. So I just said, well, if it's not 0, then do include it in my calculation. So that's how you could skip the 0.
That is awesome. Thank you so much.
I got one last question for this week, I guess. So when we return the cost within a function, like let's say I figure out the whole thing at the very end of I put the computation in there and I return the value that's supposed to come up from this equation that we do, right?
Yes.
I'm having an issue with my brain tonight trying to figure out how, if I'm going to print that final, let's say it's value, whatever, or cost, let's say it's cost, that final cost from that function, how do I just print the function I defined and it should pop up?
You can actually do it one of two ways. Let's see if I can get back to our function stuff.
Because if you call it, it exists, and then.
All right. Yeah.
Oof.
So let's go back to our example here of the cost of a car. Okay, so down here we input the year, we input the quality, we call the function cost of car, which we have here. Ultimately, we have the return cost. So out of this function, we're returning the cost, right? We're returning that calculated value. So it gets saved right here. So we're saying cost is whatever that function returned.
All right.
So that it returned this value, and these are named the same. That's just merely coincidence.
All right.
I could have called that just C and then printed out C. It was just coincidence. I called them the same thing. But you have a variable equals to the function. That means this variable is equal to whatever it returned. So you can have a variable equals that. You can also kind of do it directly. We can print the cost of a car. Let's say you're 1,000 with high quality, or HGH. You can also do it directly like that. And that's because cost of a car returns a value. It returns 5, whatever number value it returns, right? And then we print out whatever is the return of that. So you could do it either way. You could say a variable equals the return of the function and then print out the variable. Or you can just say print out the return of that function.
All right. But you have to run the function before you can return the. Oh. All right. Yeah, I think I got it. All right.
I got a chat message and saying, "Have problems printing my defined function." So what you're probably doing is, so let's say I did this right here. I just say print cost of car, right? What is that going to print out? Well, to call a function, you know, we need to have these braces. You know, we need to have those braces along with, you know, the values in there, right? That's how you call the function. But if you accidentally leave those off and you leave off those braces and you just print that, let's delete this stuff out here so it doesn't interfere. We just print out and all we have is the function name. You're not actually calling the function. It's actually significantly more complicated than that. If we run it, you can see it gives me that right there for an output. And what that's saying is this cost of car, it is a function. You're not calling the function. It's just telling you what this is. And so it's saying it is a function. It is called cost of car, and it's at this memory address. So the individual that sent me the private message, that's probably what you're doing wrong, is you're just trying to print out and you're just naming the function. You have to use those braces to actually be calling the function and using its return value. And of course, you need to give it the arguments that it needs to do the execution. And I hope that answered your question. Okay, that's good.
I have another question. And it might be beyond what we're learning right now, but one thing that I've come across a couple of times is when I have a computation inside of a definition function, and I'm trying to incorporate or call that function, but I can't get, I guess because it's only, the computation's only local to that function. I can't get the for the whole program to compute together. I don't know if that makes sense. Like they don't recognize each other, so I can't get what's going on in the main body to compute with what's going on in the function that's being called.
Okay, so let me make sure I understand your question. So for example, if I did something like this, print cost. So this cost, you know, exists within this function, right? It's not part of main. Is that kind of what you're asking? Is how can you use a variable that's inside the function?
Yes.
Okay.
Or at least like if I wanted to do something like, you know, if I called the function inside the main body and I want them to sum the calculations that are in the main body up with the calculations that are done in the function.
Okay, so I think I understand what you're saying. So let's say let's stick with the same example. We have a bunch of cars and we want to figure out what's the sum of all the cars, right? So let's give my input. I don't need my input. So let's have, say, a sum. It'll start out to be 0. And let's say the cost of this car, let's get the cost of that car, right? The cost is calling the function. So the C is the return value, right? So I can have my sum equals the sum plus that return value. Now I can do that as many times as I want. Say 2,000, 3,000, right? And so each time through here, I'm calculating the cost of a new car, right? These are all different cars that I'm getting the cost of. And so the return value is saved in this variable, right? The C is equal to the return value. And then I'm just adding that onto the sum. And then at the end, I can just print out the sum. And if I want, I can print out the average, which in this case will be sum divided by 3 because we did 3 of the 3 cars. Save it and run it. And there you go. That's the sum of all those cars that I computed, and that's the average of all those cars that I computed. Does that answer what you were asking? Is how we can use the return value to add it into sums and stuff?
Can you scroll up a little?
Oh, sorry.
Yeah. I'm not sure anymore. I guess so. I think what the problem is this, I've never used the return. So maybe that's why I wasn't able to get
Yeah.
the
Yeah.
local variables to communicate with the program.
Yeah. If you're not using a return there, then you really can't, whatever is computed in here, you can't add it into the rest of your program in main. So
Okay.
yeah,
All right.
so you have to have that return value to get anything out of this cost car function.
Okay. Appreciate it. Thank you.
Okay.
And I got to sign off. Hey, thanks, Professor. You cleared up a lot of stuff today. I appreciate your time.
All right, no problem. I'll hang around for a couple more minutes. Feel free to drop off as you want. This is being recorded, so I'll get it uploaded and a link sent out either later tonight or early tomorrow morning.
All right, Professor. Thanks. Thank you very much. Turn it up.
Thank you. Have a good evening.
All right. All right, that's a wrap. Everybody have a good night.